Okay, you two, we've been looking at the graphs of equations or the set of solutions to an equation which does plot the points on a graph. And in order to kind of explore further, we're going to look at a very, very simple model in two equation or two variables, and that is a linear equation in two variables. And so we talk about often y equals mx plus b form equations, and these are what we call linear equations in two variables. But one of the simplest forms is this y equals mx plus b form. We refer to this as the slope-intercept form of a line. And so the reason why we refer to this as the slope-intercept form is, let's go ahead and explore a little bit here. If we substitute in 0 for our x value here, that would be the same as trying to find the y-intercept. What we end up with is y equals m times 0 plus b, which in other words gives us this b value here. So it is fair to say that the line is going to cross the y-axis at y equals b. We can see that on the picture down here. And it's also fair to say then the y-intercept has to be 0 comma b. But also when we look at this, we say that the steepness or slope of the line is represented by m. And so in slope-intercept form, which is this right here, we see that the two quantities that we mainly pay attention to are where it hits the y-axis and what the slope is. So just a quick note on our slope here. What is slope? We define slope m as really being the rise over the run. But when we simplify this down, as a matter of fact, we could look at m as being the amount of rise for every 1 unit of horizontal span here. And so we could see that this says that the slope of a non-vertical line is the number of units that this line either rises, goes up, or falls, goes down for each unit or 1 unit of horizontal change from left to right, as we see. So in terms of y equals mx plus b equations, they're pretty straightforward in that we always just graph the y-intercept. So we say graph the y-intercept, okay? And then what we're going to do is use slope to find at least one other point on the graph, at least one other solution pair, okay? So what we're going to do here, looking at this as y equals mx plus b, is get used to the fact that this is slope-intercept form where we have m as our slope and our y-intercept is b. But use that to our advantage to just quickly graph some lines here. So one thing I do want to mention before we kind of get into sketching these right here is from time to time you're going to run into a line that has no slope, and this would be a vertical line. So let's go ahead and make a note here. We have vertical lines have no slope. So vertical lines have no slope. Now this is different from 0 slope, but we're going to say they have no slope, and the reason why is just because they always rise, okay, but they never run from point to point. So we get a slope that is undefined. So we're going to look at equations of vertical lines as not being y equals mx plus b form, because we cannot write the equation of a vertical line in y equals mx plus b form because they have no slope. But we see them as just x equals a value here, or x equals a is given in this expression. But we'd say that these are all the points that have this particular x value of 3 are on this line here. So in terms of sketching the graphs of these linear equations, what I want you to see is that they are as straightforward as just finding the slope in the y-intercept. So looking at the first one here, I notice that first of all, y is already isolated. That's great. And second of all, that our slope is 2. I'm going to say 2 over 1. And our y-intercept is a positive 1. So to graph this letter A line, simply we would just go up 1 on the y-axis. We would say here's our y-intercept, and it rises 2 every time it runs 1. So we could do this a couple times. Rises 2, runs 1, rises 2, runs 1. But this would be the graph of our linear equation right here, and I just want to make sure that we do label this here. This is 2x plus 1. So we can see a line that has a slope of 2 and a y-intercept of 1. Now looking at letter B here, you might be saying, self, where is the the x value? And the reason why we don't see 1 is because we could also re-express this as 0x plus 2. So when you look at something like this, we could indicate that the slope is actually 0, or we can write this as 0 over 1, and b in this case is our 2 value here. So this line, as a matter of fact, hits at a y value of 2 and then has a slope of 0 over 1, or in other words, it rises 0 and runs 1. Rises 0 and runs 1. Rise 0, runs 1. As a matter of fact, the entire horizontal line that you see here would be the line y equals 2. So one thing to keep in mind is that we have x equals a is a vertical line, and we could say that maybe y equals b is a horizontal line. Whenever you have just y equals a constant, you're going to have a horizontal line. So now looking at this last one, it says x plus y equals 2. Now we could actually go graph this by just finding the x and y intercept and then graphing those and connecting the dots. But one thing I want to do is I want to work to get y by itself here. We're going to write y as a function of x. So we can look at this as y equals 2 minus x. In this case, I want you to be careful here because slope-intercept form, y equals mx plus b, y equals mx plus b. The slope is always the coefficient of our x value. So in this particular case, we can say that the b value is actually this positive 2, and then the negative 1 here is our slope here is m. So we have slope is negative 1, or I'm going to write negative 1 over 1, and then b is equal to 2. So to graph this line here, it has the same intercept as we did for y equals 2, except for it has a slope of negative 1. So it's going to go down 1, right 1, down 1, right 1, down 1, right 1. It's just going to continue to do this indefinitely. So here is our graph. Okay, we want to put arrows on either side to indicate it goes on forever and ever, and we can label this as just x plus y equals 2. Final thing to note here in this video is that we recognize that we had three different, I guess, types of slope, and these would be a positive slope, a negative slope, and then zero slope. So one thing to mention here is this, slopes, okay? If we have a positive slope, then it rises from left to right. And if we have a negative slope, we're going to have something that falls from left to right. So left to right. And then something with a zero slope is going to be something that is a horizontal line. So you can look at it this way. If we have a graph that has a positive slope, it's going to increase. A graph that's negative slope is going to decrease. Zero is a neutral number between all of our positives and negatives, so it'll neither increase nor decrease. And then last but not least, if we have a vertical line, okay, a vertical line here, then we would just have simply no slope. Cheers.